Okay, so let's start with number one. Let's change my font size there. It's just sort of setting these standard things. Total mixed discretization off. It's something related to having fluid flow and this total mixed discretization on. I think that problem has actually been resolved now, so this line here is probably not necessary. But anyway, we do need to configure the fluid, turning off the large strain, we're turning on gravity. These are just the sort of standard things. And then the next part here, number two, is actually generating the mesh, and this was done in the sketch. But you can just quickly look at the exams, the commands. It basically is, again, importing a DXF, and then meshing it, and then assigning a bunch of group names. Basically all that's happening. So you can run this file. Oh, start by running number one, then run number two, and then double click on the model plot left side there. You can see what we've got here. So the way this was built is they built the whole thing in Sketch because it's easy to do that. But in reality, when they constructed this, of course, it was like layer by layer. So what we're gonna do is start with the whole thing, but we're gonna null most of it and start bringing them back again layer by layer. Again, just easier to build the whole thing, sketch pane at the beginning, just to build the geometry and the meshing and all that kind of stuff. And we can null it and start building it up one by one. So you have this initial dam here. This purple one is called start dam. And you've got 3 layers behind that. And then they started building these dikes on top, so they could add more layers in behind here. Anyway, you can see what the geometry looks like. If we go to number 3, data file number 3, construction. It restores the mesh. It does this skinning where it automatically assigns the group names to the boundaries. Again, just so we can apply the boundary conditions. So same as you've seen 100 times already, fixing the velocity, the x velocity on the left side this time, and both velocities on the bottom. The right-hand side is the true, right? The right-hand side here is the true surface. So we're not fixing the velocity on the right-hand side, just the left-hand side, and all velocities on the bottom. Again, we give a fluid constitutive model, which in this case is isotropic. Again, same we thought before. A permeability and a porosity. But we're going to start with just the mechanical part here. We're turning off the fluid. We turn everything to null. So this is what I said. We're going to turn everything to null, and we're going to bring back these layers one at a time. Right? And they've actually done it with a little fish function, because every dam layer has the same properties, and every dike layer has the same properties, and every tailings layer has the same properties. So instead of typing this out over and over and over again every time we add a new layer, just put in a little fish thing so we can call it, and it will set the properties to the group name that we specify as input to the fish function, right? So we input to the fish function the group name that we're bringing back and the type of thing that we're bringing back. So it's either dam, dike, or tailings. And then it goes through here and says, okay, it's currently null, but I'm going to change it into more Coulomb. And I'm going to assign the properties. I'm going to initialize some stresses. And then I'm going to do a solve. So in this way, you can do it layer by layer by layer by layer. Down below here, you can see commented out when they did it by hand, right? They just did layer by layer by layer by layer by hand by just typing in every one, its name and its properties and its initial stress, and its name and its properties and its initial stress, solving and saving and solving and saving and so on. So you could do it that way. If you don't like fish, you can just type these things out, bring all these layers back one at a time. The person who actually did this said, you know what, I don't want to type all that stuff out over and over again. I have this little fish function. It takes the group name, type of thing. Depending on the group name and the type of thing, it's going to set the properties, initialize the stress, and run a solve, and then do a save. And it gives a name, a unique name to the saving. Is just every time you call this fish function, it just increments this counter, so that we have a whole bunch of saved states. You can see over here on the left-hand side. Doesn't take long to solve, but I gave you all the save states. It actually does 18 different stages here. Instruction. And so you can see here it's calling the fish function multiple times and giving it different group names and different types to build this thing up bit by bit. So you can actually run this. It doesn't take long. You can actually just run this file, and you can go over to the model and watch it go. See, it nulls everything, starts with the dam, adds the next layer, adds the next layer, adds the dike, adds the next layer. So it was kind of fun just watching it go. Right now, this is all more Coulomb, and this is a typical way of doing these things, because a lot of the soils models, most of the soils models, require some sort of initial stress state of work. So what you either have to initialize the stress with a command, or you run it first with like something like more Coulomb to get the initial stress state. In this case, initializing the stress with a command might be a little bit challenging because the geometry is. If it was like perfectly horizontal, fine. Because this geometry is a little bit weird, it made more sense in this case to set it to more Coulomb, do all the mechanical stuff, get the initial stress state, and then it's going to use that when we flip it over to a more complicated soil model, which in this case is North Sand. And that's a pretty common way to do this.